This would be like unit 5. I'll use the default. Okay, I'm going to create a package. I'll just call this as the control structure. And I'll just create our main program. And this will be the simple main program for now with the main method. Alright, so when you test something, you will put that into a condition, and that condition will go into the head or the block of the head block of the if block. So we do something like if something is true or false. It doesn't matter how you want to set that up. You have a the block of or the body of your code. So we'll call this as the if block. Okay. So here the word if followed by a pair of parentheses. Again, that's required. You may make sure you put that in there. I know some languages don't require the parentheses at all, like in Visual Basic, you just put if A is equal to B, then something. But in most languages, Java, or most of the languages that are derivatives of C, then you have to use the parentheses in there. And the condition will be anything that is a truly type of condition. We'll say truly is something that is output into a true or false scenario. Okay, so whatever you put in there, it has to be either true or false. Okay? It can't be like, if it's something, just something, like A is equal to 10, which is fine. And you have to test if that is true or not. Okay, so, and that deals with operators we'll talk about in a minute here. So let's just say we're going to test something, and the easiest one is just say 1 equals 1, right? That is always true. And notice also the double equal signs there. Okay, this is the equivalent or the equal operators, where we compare two operands and to see if those two are equal or not, and we'll use that double equal signs. Okay, versus if you just put a single equal sign, then that's the assignment operator, and that is incorrect here. So if you say if 1 equals 1, then that is true. Then we'll go into the block of the block here, and that is the block inside a if block. Okay. And if you have only one statement, let's just say if that is true, then I'm going to say I'm going to output something like just a phrase or a sentence or a word, true, right? True 1 equals 1. And you don't have to put the curly braces in here like I did here. If you don't, if the statements here is just a single statement, then the curly braces are optional. Okay, it's not required, but I always recommend you put them there, just so you can easily see your code and you don't get just by some instances you have unexpected errors in your code. Okay, so in other words, you could do that, or I can just completely take the curly braces out, and that will still be fine. Okay. The only problem is that if I forgot to do that, and if I think that if 1 equals true, they're going to print that out, and then I'm going to assign. Let's just say you have another variable here, maybe like a Boolean type of found, and you set that to false, right, or something like that. And you might think that since 1 equals 1. Then I'm going to print that out, and I'm also going to say found is now set to true, right? As you can see, it doesn't give any error. But the output will be, totally different from what you might have in mind. And so in this case, found will always be true because this statement number 12 is not a part of that if block, right? Okay. So just be really careful with this one. If you mean to use found to be true only when the case where 1 equals 1, then you want to block put that in the block of code. So both of those statements will be a part of that if block. Otherwise, it would just run the first statement. If that is true or not, doesn't matter what that is, then line 12 will run regardless. Okay, so that's really tricky there. Okay, so instead of 1 equals 1, we can then say, we can put an integer up here. We'll have like a number. We'll set the number to 10, for example. And then we can check for the number 10. We can say if, instead of 1 equals 1, we can say if number equals 1, right? If it is equal to 1, then that is an exact value equal to 1. Then we'll print that statement in line 12, and we'll set the found to true. Okay, so and then we'll exit out of that block. So you can test for the equivalence of two values. You can also test for less than or greater than, right? So instead of equal, you can say number is greater or equal to 1, right? That's including 1, and or less than or equal to 1, right, and so on. So let's just say that if I say if number is greater or equal to 1, then print this statement. And if you also want to say if the number is equal to exactly 10, right? And you can run another statement here, and we'll put another output here. Just say, number is 10. And then you can put another block and say if a number is so not equal 10, right? If it's not equal to 10, then we'll just put another statement here. It's the same thing, not equal to 10. So this is another thing that you might run into is these two angle brackets here. Again, this is not a valid operator in Java, although you might be tempted to do that. And other languages maybe, like especially in databases and SQL servers, that is a not equivalent or not equal to. But in Java, you would use this pound sign and then the equal sign. That's not equal to. Okay, so this pound sign, I mean the exclamation mark here is the not. It's the reverse of true. So it's not equal to 10, and then we'll output number is not 10. And we should probably change this up here just to make a little more sense. Let's go change the output here. We'll just say number is greater than or equal to 10, right? Well, actually, I mean 1. So if you were to run this program, we're going to get two statements. So the first one should run, and the second should run, but the third should not, right? Because it's not equal to 10. So if you run right now, output somewhere. So we have number is greater than or equal to 10, which is true, and the number is exactly 10. Okay? And the third case is not true because it's not equal to 10. So this is pretty straightforward. Only thing is that if you see these three, blocks of statements here, it's kind of redundant in a case that you don't have to test every case in this scenario. You could do something about this to make it even more convenient or more, I would say, you can rewrite this to make it let's say, more concise or more precise, make your code much shorter. You can combine these into maybe a single, even a single statement, or not single conditional test up here, and the line 11. You could do that as well. The difference between this and the next one we're going to write is we're going to combine all these together. Or we do the first two. Let's do the first two first, and then we'll do the rest. So this is by you testing every condition separately with an if block, right? So if that's true, do that. Otherwise, if that is true, then and so on. As you can see, there's no else block here. We'll do the else part in a bit here. But I could rewrite these into a compound condition. Okay, using compound conditions. That means you can join two or more conditions together in a statement. Okay, so we can join like line number 11 and 16 together. Okay, and we'll have a similar output, but maybe a little bit different. So we'll say if number is greater or equal to 1, right? If that is true, and then you can join two conditions together using the AND or the OR operator. And the AND is just basically the 2 ampersand here, right? So let's say using the logical, we call this logical AND. Okay, it's tested logic. So logical AND. Let's say if number is greater or equal to 1, and number is equal to 10, right? We'll see if this makes sense. Then we're going to say, going to output, let's say number is greater or equal to 10 to 1, and is exactly 10. Right? If that is true, then we should see that statement there, printed out on the console. So, I mean, when you test your condition, you have to make sure if it really makes sense or not. Can a number be true in both cases? Because when you do it AND or the logical AND, you're joining both together to make sure both have to be true, right? If you remember your truth table, a true and a true, you get a true. So in this case, we're testing two conditions. The first part here, if number is equal or greater to 1, that is true. And the number is equal to 10, in this case, it is. If that is true, then the entire condition is true, right? So true is true. And so in this example, we should see that statement printed out as well, including with the first two up there. Okay. So you'll see that the first two are true, which we know already they are true. So when you test it, when you combine those together with the AND, with the logical AND, you also expect that both of those should be true. When you use the logical AND, it will do the logical OR as well. Just be careful because sometimes it can be really tricky. Like, for example, if you say, for example, a number cannot be both negative and positive, right? So you can say if number is greater than 0 and number is less than 0, it makes no sense. So in that case, it will always be false. It can't be in both states at the same time. Okay. So that's the logical AND, and the logical AND and the logical OR are similar in nature, except I'll explain in a minute what that means when you have the what's called a short circuit condition. So we have the logical OR, and this is by just using the OR symbol, which is the two pipe symbols. So we can say if number is greater or equal to 1, or the logical OR is those two pipe symbols, okay, together. You can't put a space in between. If you do, that's incorrect. Okay, so make sure they're like together. Same thing with the logical AND up here. If number is greater or equal to 1, or number is equal to 10, then we can say number is greater than equal to 1 or equals or is exactly 10, right? This means that either one is true. If number is 5, that will still be true, right? This number is greater than or equal to 1, but it doesn't have to be equal to 10. Right? So I put any number greater or equal to 1, even though if it doesn't matter if it's exactly 10 or not, it will still be true. Okay. So in other words, if I run this, you should see 4 statements. That should also be true. So it is greater or equal to 1 or is exactly 10. And so now if I were to change the number to, let's just say 11, right? If that's 11, then we'll get this block is true because it's greater than or equal to 1. And also when you write this, as you can see, I write like line 10 here, it's acceptable, but it's really hard to read and to see and for us to see. So you always want to make sure you put space in between those operators, just for readability, but the computer really doesn't care in this case. Okay, so this one is true because 11 is greater than that, greater than 1. This is false, so you're not going to see this number is 10 at line 17, and we'll get this line 21 instead because it's not equal to 10. And then this block will be false because 10 is no longer equal to the number, which is 11, and then we'll get the last one here. So we'll get 3 statements. Number is greater or equal to 1, not equal to 10, it's not 10, and then down here as well. So we get 3 of those statements printed, and those 2 where it matches exactly 10, and the AND operator for the 2 conditions here are not true anymore, so we don't get that output. Okay, so these 2 operators here, the AND and the OR, these are also called the short circuit operators. So the short circuit, if you think about a circuit in circuitry, is that when one is, let's say you have like 2 or 3 circuits, and when one of those circuits is I would just say meets the requirement, then the rest could be ignored, right? Something like that. So what that means is that when you have 2 or more conditions in a compound condition like this, you always test the first condition first, right? It's always from left to right. You test that first, and the logical AND will test that, and we'll see that if this is true or false, right? If this is true, then only and then we should test the second condition, right? If it's already false, then there's no point of testing the rest, because no matter what, it's going to be false anyway. Okay, so that is the short circuit right there. So you test the first one. Is it greater than or equal to 1? Yes, that's true. Okay, if there are any more, then we need to test the second one. If that is also true, then we'll keep testing the rest until all the conditions are tested. Until we find one is false, then we can stop there, and then the entire test will be resolved to false, right? So if this is already false, then we ignore the rest. Okay. And same thing here. We'll test the first one. If this is true, right, because it's an OR, then we can forget about the rest. We don't care about the rest. Whether they're true or false, it's besides the point. We already test the one, and when it meets the requirement, then we can go ahead and process the data. Okay. We test the second or the rest of the operators of the conditions here only if it's false. So if this is false, then we need to check the second one to see if that is true. If that is still false, then we keep moving until the end of the list, and then whether we can find a true statement or a true condition or not. If there's one true condition, then the entire block will be executed. Okay, so this is the short circuit here. And the reason why you use this is because sometimes, I know this is a really simple example, but sometimes you don't just see, you're comparing a number here. You might run this into another function, a very convoluted function that will call other functions or other classes, but it's still at the end, the return value will always be true or false. Okay, so when you have something really complex in that nature, it can consume a lot of CPU times. Okay, and so if you test one part, if that's true, then in this case, in the logical OR, you don't need to spend CPU time, testing the other cases at all, because it doesn't matter what the outcome is; it's going to be true anyway. Okay, so the same thing for the logical AND. So in Java, you always have this. In like Visual Basic, you have both options. You have the one where you actually test every condition regardless of what the outcome is. And again, that's going to be a lot of waste of time. And so most languages now will just use these short circuit operators here. All right, so these, again, as you can see, there's no else part. If you look back to that diagram, it's like we are reaching this diamond shape here, and there is no the other output. It's there, we just ignore it, right? So you always have the true or false. And sometimes you don't have to, really include both of them. Maybe you don't care about the false case, or you don't care about the truth case. It doesn't matter how you do it. That's up to you. Okay. So if you do need to include both cases, then you want to supply the other part as well, and that is the else part, right? So here we have just one branch. If this is true, then we just go with the truth branch. We ignore the false branch completely here. Okay. And so typically you would say, if this is true, then do this. Otherwise, okay, otherwise we do the other way. So I'm going to go back here, and I'll just say I'm going to add this if and else block. Okay. So if that is true, then do that, and then we have the else part to execute the other branch, the false branch. Okay. In this case, I say false. It could be the opposite. It could be the truth branch, depending on the first test case here, right? If you're testing for a false, then the else part will be the truth part, okay, and vice versa. So when you test something for whether the number is greater or equal to 1, you could just do this, and then say, if this is not true, then it has to be the other case, which is this has to be less than 1, including 0 in this case. So we'll say else number is less than 1. So if I turn the 11 into a minus 11, then we'll get that false part here, and the rest will be false because, well, except for number 24 here, this will be true because it's not equal to 10. So we get the number is less than 1, and we'll get the number is not 10, and then this will be ignored, and the last one will also be ignored because both of these are not true at all. Right? So we get only two statements here. Okay? Because it's not greater or equal to 1, so therefore print the else branch. And then the second statement is not equal to 10. So that is true because it's negative 11, so print that out. Okay, so very simple like that. So if you have this diagram again, I go back here. I'm sure if there's another one in the book or not, but you can actually keep going here. So if I go to the no branch, if I say if number is equal to 10 or whatever that value is, if it's false, then on the no branch here, I could do another diamond shape here, right? I could do another conditional test. and then I would test it again if the number is, if it's less than 10, then is it, greater than or minus 10. You can do all sorts of stuff. And that can keep going until we find what we want to test. So I could say if number is, so in this case we have exactly just a yes or no, right? There's no third option here. Okay? So let's just say the next one here, we're going to test for, if it's 10, we'll print that out. And we'll also test if it's, so if it's not equal to 10, is it less than 10 or is it greater than 10, right? How do we know which is which? So I could do, you could break it out into another if block and say if number is less than 10, right? So since you already test equal to 10, if it's not true, you're not going to say less than or equal to 10, right? This is redundant in a sense because we're not going to test the equivalent here for 10 anymore. We know that number 19 is already false, right? If it is, or true in either case. So we just test for the less than. If that is less than 10, then we just say output number is less than 10. Less than 10. And I'll make another block here. What if it's not less than 10? We don't know that. So we say, oh, if number is, maybe it's greater than 10. So if it's greater than 10, we'll say number is greater than 10. And here I'll put the comments here. We'll do if, else, else if, block. Okay, we'll combine these together. So in this example, this will be fine. It'll work. But sometimes if you just test for a number like this, then it's kind of redundant in the case that you don't want to run every condition. If you know that one is true, why do you want to test the other one anyway, right? So if 10 is already true, then you don't test whether it's less than 10 or greater than 10 anymore, and vice versa. If you separate them this way, then you have to test every condition, and again, it's about CPU time. Okay, so 3 lines of code, 3 statements. That's not a big deal. But imagine if you have to test it like 1,000 or even 100,000 times. That's a lot of code to test, right? So instead of doing this, we can combine all these together so that only one of those branches will run. And once any one of those branches is true, then the rest will be ignored. Okay? And this will be executed from top to bottom, so it's also important how you want to place your conditions. Which one should be tested first, right? So usually you want to test one is the most logical one. And so, and sometimes it doesn't really help. Like in this case, it could be anything. So it doesn't matter which one I put first, would still be same, right? But if a test for a negative or positive number, then the first case would be either less than or equal to 0. Or greater than 0, you test for negative first, and you can go on the negative or the positive direction. If you just test for a negative 10 or less than a negative 10, that's like you have a lot of options there, and it's not very effective. So we can combine these 3 if statements here to a single long block of if and else statements here. So you can say else if. Okay, you can join these together. So now I have what's called the if, else, if block. So if number is 10, then that is true. The other 2 statements can be ignored. We're not going to get all 3 of, right? That's kind of pointless. Unless that's your intention, then that's okay. But otherwise, you wouldn't do that. So if it's equal to 10, if its number is less than 10, so all of this will be like an or, right? If it's equal to 10 or if it's less than 10, you run that, or if it's greater than 10, you run the third statement. What if it's none of these at all? Then you still have the else part, which is, again, here, we didn't put it, so the else part is completely optional here. If you don't want to put that in there, it's completely optional. You don't have to put it in there, but you can. If you want to use that as a catch-all, it's like none of the above, then you put the else part, right? And the else part always comes last. You can't put the else part like suddenly in the second block, and then you have the else if after that. Okay, it's always the last block of the if and else blocks here. Again, that's optional. So in this case, then it doesn't make sense to use the else because it can't be any other than just those three, right? Either it's 10 or not, 10 or greater or less than 10. Unless you want to test if it's 0, then that's something else. Okay, so in this case, we're going to get the second statement where number is less than 10 because it's negative 11. So if you run that, you get that negative 10. And I might have saved that. So here we have number less than 10. Okay. So here we have what's called so in this case, every if block, every if condition is a diamond shape. So we have 3 diamond shapes here. Okay. So the first diamond shape, if number is equal to 10, if it's 10, then we move to the yes part. Otherwise, we move to the other part and we'll test for the other false part. Sometimes you do this. If this is not preferred, you can always put that in a separate line like this if you want. If that's easier for you to see, that's fine too. It doesn't matter in Java. Just as long as the immediate word or keyword is the if part. Okay. What you cannot do though is you cannot put a conditional statement in here. I cannot say if number is equal to 0. Right. The else part is always the default, which is the other branch, which is always the one that is not being tested. So you can't put a condition inside the else part. Okay, so that's the if block, and you can also have nested ifs. So I have this 3 if blocks here. I could say if number is 10, then do something else. In this case, maybe it's not a good place to put there. We could do inside the if less than 10 here, for example. If it's less than 10, I'm going to move this back up so it's nicer. If it's less than 10, that's true. Then in here, I can test again, right? I can say if number is, how do you test for if number is an even number, right? I'm not sure have we talked about that before? We did, right? Yeah, even number. How do you test for even numbers or odd number? Any idea? How do you know a number is even? Divided by 2, right? Yeah. So you can say if number is not a divide, okay, that divide will give you a division number, so you get a remainder of 0, right? When you divide something by 2 and you get a remainder of 0, then that's an even number. So instead of divide symbol, you use the percent symbol here. If it's divisible by 2, and if that is equal to 0, right, then that's an even number. Okay, here even number. And here I'm doing an expression on the left side of the double equal sign. This is an operand. So I'm testing 2 operands here. Same thing. You look at this condition. Same thing. If number is equal to 10, here I can say if number divisible by 2 is that equal to 0, then you get an even number. Then else it's an odd number. Right. So you can say else. Down here it's an odd number. So you can output here inside the first inner if block here. I could say system out number is even. And then the second block here, I'm going to say system out number is odd. Okay, so I have a nested if and else block. Okay, so I have an if and else block here. It's nested inside another if block. And you can keep going. There is no limit to how deep you go in there. You just have like one level and another level and so on. And when you do this type of expressions, sometimes it can get very confusing. So you can always, wrap these with a pair of parentheses, like the numbered. This is the modulus. This is the modulus or the mod operator. Okay, or the modulo. And here are some other languages. You can always wrap that expression inside its own parentheses, just to make sure that that part is calculated or evaluated before it does something else. Because if you don't, sometimes you might get unexpected results. Okay? Especially when you have those operators or those mathematical operators have the same precedence. Okay? So if you want to make sure, so you want to calculate something else first, just wrap those inside a pair of parens. Okay, so if you run this now, I'm going to change this less than 10. Okay, so that's fine. 11. So you're going to get number is an odd number because it's it's not an even number. Okay, so even though it's a negative number, it will still be an odd number because you divide it by 2, you still get a remainder of 1 in this case. So anything that is not equal to 0, and then for the remainder, that is always going to be an odd number. Okay. Okay, so these are just the if and else block, and that's all there is basically. You can combine multiple conditions together using compound. You can mix and match as well. You don't have to use all and or. I could use both of them. I could do something like down here. The logical, I could use both of these logical and or together in the condition here as well. I could say if number is greater equal to 1, okay, and number or say or number is, let's put a paren here, say number mod 2 is equal to 0, right? Equal to 0, that's an even number, and say number is it's greater than 1 if it's even number and if it's 8, right? If it's equal to 8, then the whole thing is true. I'm testing 3 of them. Well, in this example here, it's kind of, so you have the or and the and here. And in this case, like, how do you know which one should be tested? Because it's confusing, right? So what we're going to do is you can group this together. You see, I'm going to test just to make sure that the number has to be even and it has to be 8, right? So you can put these two together in one pair if those two conditions are true, and then you can also test it against the or part. Okay. If you don't, then that will be true because the first case is true already, and this part is going to test just these two here. Okay. Or if you want to say, I want to test this 2 first and get the result out of those 2, whatever those are. If it's true, then I will say true against the number equals 8 or not. Okay, so where you place those parentheses is really important in your condition. Sometimes you have to do that just to make sure you get what you want. Otherwise, it'll get a really unexpected result, and you may wonder why. and it can be very difficult to debug. Okay? So in this case, I'm going to say a number has to be greater or equal to 1. It has to be even number if that is true. In this case, this is already true. I can ignore both this part, right? So number is negative 11. So this is false, and this is false, right? So therefore, this whole thing is false. And so since it's false, again, it's against the true with the end, you're going to get a false anyway, so this thing is not going to run. So we'll say, I'm just going to put this in here. Okay, this won't run because it's false. Right? So you won't see that in here. Because this is false, false, you get a false, and then with the end you get also false. Okay. If we change the 11 to, let's just say, minus 10, or if you use the minus 8, for example, it will still be false because this will never equal to 8, right? So even though this is both of these here equated to true, it will still be false because it's not equal to 8. So in this case, again, you're not going to see that last statement. Because I wrap these two together. It'll be different, however, if I ignore the first part, and if I put these two together at the end here. That'll be a different story. If I wrap these two together as one group, okay, it's not positive, so it must still be false because it's not positive. But if I put a positive 8, then that will be true, because now this part is already true, and it's an and, it's an or against the entire operand over here, so that's already true. Okay, so you can combine these together, and if this is too confusing, break it down to separate if statements here. You go one layer at a time. So you can test for this is true. If this is true, you can nest this inside that. If that is true, you can nest that inside here. So really, I have like 3 nested ifs in here if I want to do that, right?